Hello everyone. I am Lorello. I am a developer advocate, specifically .NET developer advocate at Redis, and we're going to be talking today about indexing, searching for things, and aggregating things in Redis using RediSearch and .NET. So I'll probably help if I click on my slides. So I like to, before I give a talk, I usually like to give a little bit of an agenda of what I'm going to be covering in that talk. So we're going to start out with a brief introduction of Redis. I suspect most of the people that are watching this have heard of or used Redis in the past, but all the same, I'm going to give a little brief intro into what Redis is. Then we're going to look at some of the key data structures in Redis, and then specifically how they can be used for building secondary indices in Redis. Then we're going to be building secondary indices with essentially any version of Redis that you'd find. We call it like just traditional OSS Redis. And then we're going to be looking at building secondary indices and then querying and aggregating things all with RediSearch, which is an extension of Redis that my company Redis actually writes and maintains. So what is Redis? Like I said, probably most people have heard of Redis. I think typically when we ask the question, like 70 to 80% of people know or have used Redis. But Redis is a NoSQL database. It's completely in memory. It's fundamentally a key value store. So usually most people will use it just as a simple string key value store. They'll do like sets and gets on different strings. But because of the way the data structures work in Redis, it is actually multimodal. It can be used for a ton of different applications. And the reasons why it's so popular, and it's really popular. Like, I think it's probably the most starred database on GitHub. It is one of the most beloved databases according to the Stack Overflow survey. And the reason it's so popular is because it's really fast and it's really simple to get up and running with. So that brings us sort of to the data structures in Redis. Now, Redis is built around a bunch of different data structures, and 5 of them that we're going to be looking at today are strings, sets, sorted sets, hashes, and JSON. Now, strings are a single key that retrieves a single value in Redis. That value can then be encoded to a bunch of different types, like numerics and just traditional strings. But they're fundamentally the most basic data type in Redis. And I will say that most of the people that use Redis use it as a cache, and they never really have to look beyond this data type. So the set foo, var, get foo are the things that people traditionally use when they're using Redis. Sets are a set of Redis strings in Redis. So like a set is a mathematical set, right? It's an unordered set of strings. It doesn't allow duplications, and you can perform different set operations between them. So for example, you can do intersections, differences, and unions. So if you're familiar with sets in math, like a union is the combination between two sets. A difference is the items that appear in the first set that don't appear in the second set, and an intersection is the commonality between two sets. And you can actually perform these set operations pretty easily using Redis. So sets are built around a bunch of commands, but the fundamental one that if you've used a Redis set before that you have seen is sadd or sad, like we used to like to call it. But sadd basically adds a string to a set. So in this case right here, I'm adding this key, so person : name : Steve, and to this key, I'm adding person1, so person : 1. So now this key right here is now a set of person : 1. Actually, I'll just fire up Redis real quick and sort of show what I mean by this. Let me zoom in a little bit so folks can see. So let me just fire up Docker run -p 6379:6379, and I'll just use the image that I'm going to be using for the rest of this, which is Redis Labs / Redis JSON. Now, if I open up the Redis CLI, let me zoom in a little bit more. You'll see that we have these different data structures. So the first one we talked about was strings. So if I want to set foo bar, I can do that, and then get foo just brings back bar. I can also store things like numbers, like set num1, and then I can like increment numbers, or anchor num to incremented, or I can increment my num by 3, and that increments it to 5. So like it has different encodings too. Now sets are arithmetic or are mathematical sets. So I could do sadd my set foo bar baz, and then I could do s members of my set. And that'll get you back all the members of that set. But if I keep adding to that set, so if I keep adding foo bar and baz to it, because it's a set and can't have duplicates, you can basically just get the items from it, the items that have been added to it a single time. So where this becomes really powerful is if I want to have a second set, so my set 2, and I'm going to have foo and bar in here. I can then do things like find the intersection between my set 1 and my set and my set 2. So senter my set 2 is just going to bring back foo and bar. Sdiff my set 2 is just going to bring back baz, because my set contains foo and bar, but not baz. And that's that difference there. And then S union is actually going to be the same as my set, because all 3 are in that same set, right? All 3 in those 2 sets. So why is this important? We'll get into that in a little bit, but that's just a brief intro of like what sets are. Sorted sets are really similar to sets, in that they are also sets, but instead of just being an unordered set of members, they are, as the name suggests, sorted. So you can store things like numeric data or even lexicographic data in sorted sets. So sorted sets are very similar to sets in the commands that they expose. So except usually they start with a Z, or they actually all start with Z instead of S. So if I do like a Z add here, and I add to the key, so the sorted set person : age, I can then pass in a rank or a score and a string. So the score is 32, so like passing in person : 1 as 32, and then I can pass in person : 2 as 45. And that actually allows me to then query them by their different ranks and scores and stuff like that. So that's a sorted set. Hashes are where we actually get into things that are a little bit more complicated than just flat strings. You can actually start to store objects in Redis with hashes. So a hash is basically like a dictionary. It's like a flat key value store of Redis strings. So you basically add to a key. So person : 1 in this case, I'd add like an age and 32 and a first name, which is Steve. And then this person that lives in Redis now as a person object almost, with an age of 32 and a first name of Steve. So I'll just show you this all again. I'll show all this again. So age set, we'll say person : 1 is age 32, names or first name Steve, and then I can get an htall person : 1, and that'll return the age and the first name of the person I've stored in Redis. Now, those are hashes, so they're great for like really flat objects. You can also store more complex objects in them if you maintain the sort of patterns around how hashes are supposed to be stored when they have more complex data in them. And usually that just means changing the field names so that they correspond to the objects that things are being stored into. But actually what's easier than using hash is using JSON. So JSON is something that people would traditionally store in Redis, but they would store it as a string. But there's actually a data type called, that's the JSON data type now, where you can actually store JSON objects in Redis and then access and update them by a JSON path. So this is great for actually storing more complicated objects and storing documents in Redis. So I can do like a JSON.set person:1, and then pass in this JSON string, and then you can actually query the different components of it. Now, JSON is available as a Redis module, which is a source available package that you can actually use in your own applications. It has different like licensing things that go along with it, but it is free to use if you're not using it as part of like if you're not building a competitive product to it. So just to show you what that is, let me flush the database out, and I can do a JSON.set person:1, and then I have to pass in a path. So I'm just starting at the base path, and then I'm going to pass in first name is Steve, and age is 32, right? And then I can do like a JSON.get person:1, and I can say I just want to get the age, and it'll return to me 32, or my first name, and it'll get me Steve. Or if I want to do a JSON.set and I want to go back into person:1, I could then just set my age as 33, and then when I go to get that again, now it's been updated to 33. And I can, of course, just get the whole object back by passing in the base JSON path. So now you can start to see that you can actually store more complex objects in Redis using Redis JSON. But where does this get interesting when it comes to indexing and finding things in Redis? So fundamentally, like I said, Redis is a key value store. So the way that people would usually query Redis is by querying their keys. So person:1 is great and super fast to look up if I just want to find a person who has the ID person:1, but that's not how we usually access our data, right? We're usually looking for other things related to our data. Like, for example, in our person example, you might want to find all the Steves, or all the people who are 32, or all the people who are between 32 and 35. Well, you can do that with Redis too. Like with the older versions of Redis, we're always able to do this, but it's actually the indexing and the way you can actually do that is a little complicated. We're about to get into that using a conglomeration of those data structures that we just looked at. So you can't just say, you can't just like issue a SQL query against Redis. You can't just do like a select star from people where first name is equal to Steve, or select star from people where age is less than 35. You have to build a secondary index to actually do this. So what's a secondary index? They're an efficient way to find items in the primary index, is basically what a secondary index is. The primary index for Redis are the key names. So person:1 is a key name. So the primary index that you need to be able to find is that key name. Secondary indexes usually need to be explicitly declared, and oftentimes they have to be separately maintained and updated. So let's look at secondary indexing in vanilla Redis. Well, like exact matches are things that you can, exact matches like, so saying, is this person 32, or all the 32-year-olds, or all the people named Steve, you can do that with sets. For numeric exact matches, yeah, you can do that with sets too. For anything that's like sorted or range queries or anything like that, or full text searches, you're usually going to need to use a sorted set. So let's look at our person example again. So person:name:Steve, that was the set that we built initially, right? Or that we were looking at initially. And if we wanted to find all the Steves, we would basically create this set and then insert all the people who have the first name of Steve into it. And then when it's time, we would come back through and query. We would query this set to see who all the Steves are, and then we would go through and we would pull them all out of Redis. So let's look at that exact match scenario. So for an exact match, if you store your document in Redis, you would store it as a hash, and then for each field you want to index, you basically take the index name, colon the field that you're indexing, colon the value, and you would create a set. And then you would query that set whenever you need to actually find something in it. And if you want to run more complicated queries, you'd have to do things like set combination and stuff like that. So let's actually look at that real quick in Redis. So let's go ahead and say, well, I think I flushed my database already. Yeah, so there's nothing in here. So let's do an hset person colon 1, and then say first name is Steve, and last name is Lorello, and age is 32, right? So if I did an hget all on person 1, I would get all that stuff. But if I wanted to index my first name, all the people who are named Steve, I would just do an sadd person colon first name colon Steve, and I would store person colon 1 in there. And then when it's time to find all the Steves, I can do s-members person colon first name colon Steve, and that would bring back all the Steves, right? And then I can use these all the keys are in here, and then basically do an hget all. So I had to do this combination of commands to get this. And if I wanted to find all the people that are whose first name is Steve and whose last name is Lorello, I can do it s-enter person colon first name colon Steve and person colon last name colon Lorello. And this is not going to return anything because I didn't build this second set. But basically, this would build the intersection between those two. And that's basically your ands. And then your ors are s unions, and then your nots are like s diffs and stuff like that. But you can do this though. Like this is something that you can do with any version of Redis. For numerics, you would use those sorted sets that we talked about earlier. So I would say zadd person colon age, right? And I would add 32 as person colon 1 and 33 as person colon 2. And then I could do a z range by score. And I would say, I want to find all the people who are between 32 and 33, and that would return person colon 1 and person colon 2. If I just want to find all the 32-year-olds, I could just say 32 to 32. Same thing with all the 33-year-olds and like that. And essentially, you can do these numeric range queries as well with z ranges. Now, the benefits of this approach is that it can be done using any Redis instance. You don't need to pull in any modules or anything like that. It allows you to take total control over the data that you index and the data that you don't. And I somewhat facetiously add in here that it's excellent for job security, because the con to this is that it is very complicated to do any sort of data modeling with any sort of extensive data modeling with this. The trivial examples that we just looked at here, things that you could probably get away with, but like it gets complicated when you're doing more complicated things. And the biggest downside is that it's impossible to horizontally scale your database and maintain any sort of atomicity when you're updating your data. And what's the reason for this? Well, in Redis, basically, when you shard your databases, you need to have all of the commands that are being executed in an atomic operation hitting keys that are all on the same shard. And because you're now talking about different keys, like, right, you're talking about multiple sets that you're looking at, multiple hashes that you're looking at, you need to be able to specifically locate where in Redis they are, and they all need to be located in the same place, or you're not going to be able to operate on them atomically. And Because of this, this becomes very difficult in clustered environments when you need to horizontally scale. And if you are working in a cluster, you're going to need to regularly go through and do consistency checks and updates throughout your cluster. And so that brings us to Redis search, which is sort of like the topic of, this talk. You know, what is Redis search? Redis search is a module of Redis that's maintained by Redis. It allows you to define the schema of an index, and then Redis will automatically take care of indexing and everything for you. It automatically take care of all those cross-sharding concerns that you have, and then it provides all sorts of numeric queries, text matching, full text, even like geo-searching capabilities. And it allows you to, like I said, index atomically across shards. And it is available under that same source available license that I was referring to with Redis Json before. So you can spin up Redis search with Docker. You just saw me do this with the Redis Json module, which actually also has Redis search in it. But Docker run -p 6379:6379 Redis labs/Redis search will get you up and running with Redis search. And the source is all available on GitHub that you can download and build yourself if you want to. And I think there's probably an apt-get package for Linux. It's readily available. Creating an index in Redis search basically is just declaring the type that you're storing everything in. You can either store your indexes, the data for your indexes in hashes or JSON. So either of those data structures that we referred to earlier. Indices can be declared on prefixes, so you don't have to index everything. So for example, I just want to declare all of my person : prefixed keys as in that index. And indices can contain a schema mapping fields to index types. And there's 4 index types: tags, text, numeric, and geo. So tags are great for exact matches and even faceted matches as well. What faceted matches mean is like if you could look at like different, well, tags is for lack of a better term, that a particular field has. Text is great for full text search. It is actually designed for full text search. Numeric is for numeric data, and then geo is for geolocation data. Now, the raw query language in Redis search is, pretty straightforward. You could basically, for tags, it's use the at symbol, the field name, colon, and you pass in the search data. For text, it's the same, except you don't need the colon. For geo data, you basically use a geo filter, and you pass in the field name that everything is based off of, the longitude, latitude, radius, and unit that you're using. And then for numerics, you basically just have a numeric range with lower and upper bound. And that's basically it for querying. So let me actually show you all a little bit of this. So let's create a person index. So I'll do ft.create, and I'll pass in person IDX. So we'll call it person index on hash. And I will say that the prefixes are prefix 1 person, and then I'll pass in my schema, which is going to be first name, tag, last name, tag, age, numeric. Now, if I just do an H set and I pass in person : 1, first name Steve, last name Lorello, age 32, I can just then do an ft.search, and I can pass in person : IDX, which is my index name, and I can say first name is Steve. Oh, I forgot a colon. And it'll find that person in there for me. And so it's that easy. So like you basically declare your index, and then as things are inserted into Redis, it will go through, and if it matches the prefix, you don't even have to pass in a prefix, but if it matches the prefix, it will just automatically generate the index for you, and you can actually go through and go about your day and find things without having to do all the headache and overwork of basically self-indexing everything like I showed you all a little earlier. Same thing for age, right? Age is going to be between 30 and 35, I would say. And I could even do things like return age. And it would just bring back that person name and their age, right? You could do, you could basically set age to be something that you can sort by, same thing with all the tag fields and stuff like that, and then you can order things. There's all sorts of different things that you can do with RediSearch, and we'll get into that in a little bit. So, but before we get into doing that stuff with .NET, we're going to look at aggregations and the different things you can do with aggregations. Aggregations are basically you can take your data that's stored in Redis and build pipelines of data that transform your index data in Redis. And then you can group like items together and then run reductions on them. And then you can filter those reductions and the results of those aggregations further down for other operations in your pipeline. Apply functions are something you can do with aggregations. They're sort of like maps or just traditional aggregations in .NET. Basically, you can apply functions to your data. So say we have an employee data that we're working off of, and they have sales and like maybe a regional sales adjustment. You could basically combine that stuff. So you can take @sales times @sales regional adjustment, and that would combine those two fields together to get you something that you can use further down the pipeline. And then you can like order all of your salespeople by like their adjusted sales or something like that. This provides you the ability to do a variety of different mathematical string and timestamp functions and even geolocation functions on your different data. And then you can store the results of those apply functions in that pipeline and then use them further down for more reductions or other apply functions or other group bys and stuff like that. So group bys and reductions are basically grouping like objects together, and then they allow you to run reductions on them. Reductions in this case are like sums and averages, standard deviations. There's quantile, which is a median kind of thing. You can get random items from the group records, all these sorts of things that reductions allow you to do. And then group records can also be passed further down the pipeline. And that brings us to, I'm sorry for the brightness transition, I just noticed that. That brings us to actually the .NET portion of this talk, which is using all of this in .NET with this library that we built, I built, called ResOhm, which basically provides a declarative syntax for index creation, a fluent API for searching and aggregations, and basically object mapping between your domain objects in .NET and Redis. So I will pop out of here and I will open up my command prompt. I'll zoom that in for everybody. And then I will cd projects, Redis, and I will do a .NET view console-n, and I'll just call this test RedisOhm. cd into that. And the first thing I'm going to do is just add this library to it. So I'll do a .NET add package redis.ohm start and open this in Rider. And when this opens, the first thing I'm going to do is create basically a document that I'm going to store in Redis. And because this is my talk and I get to use the documents I like, I'm going to use Muppets. So I will create a class Muppet, and I will give my Muppets a string first name. I'll also give them last name, give them a personal statement. I'll give them ages, and I will also provide a geolock for them. Basically saying where they are. Now, this Muppet class is the main object of mine. I can now declare something that I can store in Redis by decorating it with a document attribute. And I can even say what prefix I want it to use. So I'll say prefix is equals new Muppet. And so this is going to be the prefix that I use for all of the keys that are generated from this. You know what? I'll give it an ID too. And I'll call this a Redis ID field so that I can actually use this now. So right now, this is just basically creating a document in Redis whenever I pass it in. So if I go into my program file, I have a little group of Muppets that I like to use for my examples. I like to use Kermit, Beaker, and Bunsen. That's just a personal preference. I can create the Redis connection provider, which is going to provide all the connection logic that I need to basically connect to Redis. So I'll say var provider equals new Redis connection provider, and I'll press in Redis localhost 6379. This is a Redis URI. Let me zoom this in too so you can see it. Basically, you're saying Redis, and then localhost host 6379 is my port. And I can insert Kermit into here by saying provider.connection.set Kermit. And this is going to actually add Kermit to Redis and then retrieve the key that it created for Kermit. And then I can then reinitialize Kermit relatively easily by saying provider.connection.get Muppet Kermit ID or Kermit key. And then I can do something like the console.writeLine. Also Kermit.first name and also Kermit.last name. Now, if I run this, and I did everything right, which I think I did, you'll see that down here in my console, it printed out hello world and Kermit the Frog. Now, I'm going to go into Redis. I'm going to flush it real quick. And I'll monitor. You can see, you'll actually see kind of behind the scenes what this is doing. You'll see that it's actually doing hset. It's passing in Kermit's ID, and then it's passing in Kermit, the frog, their personal statement, their age, their home location, all that kind of stuff. And then when I retrieve it, it's doing hgetAll and retrieving Kermit for me. So that's not that interesting, but it's something that you can do. Now, if I actually want to declare that I want to index all of these things, I can do that. So all I need to do to index something with Redis own is declare it as either indexed or searchable. Indexed would create basically exact match searches and faceted searches for my documents, and searchable will create a full text search. So if I'll just, for the heck of it, index all of these fields, except for my personal statement, which I will leave as searchable. So I've indexed my home location, age, first name, last name. And then all I need to do in here is say provider.connection.createIndex, pass in the type of Muppet, and that will create my index for me. And I'll do a provider.connection.execute, and I'm just going to flush a database every time so that we don't get duplicates. Don't do that in production. It's not a good idea. I misspelled flush DB. Nice. So if I go back on my monitor, you see that it actually creates the index for me. So it goes through and actually creates this whole index for me. Now, I can now add all of my Muppets. So I'll do a provider.connection.create or set permit. And then I'll just do the same thing for Beaker and Bunsen for my other two Muppets. And now all three of them will be in Redis. And now all I need to do to actually query things in Redis is I can just do like an await for each var Muppet. And well, I need this Muppets collection. So I'll say var Muppets equals provider.Redis collection Muppet. And this will create a strongly typed Redis collection, which is an iQueryable for my Muppets. And with this, I can now start querying things. So querying with the Redis collection is pretty easy. So I could just say Muppets.where x.firstname equals permit. And I can just do a console.write line and pass in Muppet.firstname and Muppet.lastname, and it'll print that all out for me. You see that it actually went through and got Kermit the Frog. If we look in Redis, you'll see that it actually issued the query appropriately for Kermit. Now, if I want to find all of the Muppets that are less than 65, so that's going to be Beaker and Bunsen in this instance, because Kermit is they're all dated from their first appearance on the show. That's their age, however long they've been on the show. And I believe Beaker and Bunsen are both around 43, 45. Yeah, there you go. So if I want to find all the Muppets that are less than 45 or less than 65, I can do that by doing this same thing, except of course in this case, I would just find all the Muppets whose age is less than 65. And that will do the same thing. It'll create the same correct query for me, and it'll return Beaker and Bunsen. Now, if you want to combine different predicates, you can do that as well. So if I want to find all the Muppets greater than 44, trying to think of a good one. Well, yeah, let me just do x.firstname equals Beaker and x.lastname equals Meep, which is what I put down for Beaker's last name. And that will just return Beaker for me. Now, I can also do things like do exact text searches, or what is it? I can do full text searches on the personal statement because personal statement is marked as searchable. So I can go back into my program here, and I could say all the Muppets that are scientists. And all that looks like is you're doing the equal search, except you're using that searchable field. So hopefully I spelled that right. And when it goes through, it'll find all the Muppet scientists, except I probably didn't spell it right. And oh, no, it's not that I didn't spell it right. It's that I used the wrong attribute. So I have to use the personal statement attribute, which, like we said, was marked as searchable. So I can now go through and run it, and it will produce Beaker and Bunsen, because Beaker is a lab assistant and scientist, and Bunsen is a scientist and inventor. So that's basically full text search, range search with ages, exact matches. You can also do things like you could do geo queries too. So the examples that I'm using here are all Muppets that are theoretically located around Hollywood. So let's take a prominent example of a restaurant in Hollywood that maybe they're going to go out to dinner or something like that. I use Nobu's in this example, and I use like an approximation of the geolocation of Nobu's. I can go into Redis, and I can say dot geofilter, and I can pass in the x.home location, and then I can pass in the longitude, latitude, radius, and unit that I want to use. So Nobu's dot longitude, Nobu dot latitude. Then I can say 10 miles. And in this instance, I think all the Muppets are going to be within range. So we're going to call this all Muppets within 10 miles of Nobu's. And I can say console.write line, same thing. Except probably should spell Muppet correctly. And in this case, yep, all three Muppets that are in the set are all within 10 miles of Nobu's. And you'll see that in this case, we went through and we basically passed in star as our, as our query text. That star is a wildcard, means anything. And then it passed in a geofilter with the home location, which is the attribute that you're using. And then basically the longitude, latitude, radius, and unit of the radius that you're using. And it uses all that to create this, query for Redis. Now we could chomp that down too. We can basically say, well, what about maybe 10 miles isn't good enough? Maybe we want to do 5 miles instead. So all I have to do is say 5 miles. And this is more to show that this is not just returning everything. It should just return Beaker and Bunsen, who are within 5 miles of Nobu's. So basically it's going through and just drawing a big circle around the location that you provided, and it's saying, all right, well, any Muppet within this distance of this point is something we're going to include in our result structure. And this sort of takes care of all this for you. So you can query these things, and it'll return them back to you as the full Muppet object that you're expecting. Now, let's look at doing embedded queries. Like, so what if we wanted to like embed a document? So say I want to embed an address, and I want to have the address have a string city, and I will set this as indexed and zip code. Both of these are going to be indexed. Now, if I wanted to have an address for each of my Muppets, I can do that by saying address. And now this address field in here is going to be part of the Muppet document. But because I declare this as index and it's an object, it's actually not going to automatically index it. I actually need to provide it a cascading depth that I want it to go down. So if I wanted to reach just one level down into address and index everything in address, then I would say, all right, cascade depth is 1, go down to address and index everything in there. Alternatively, I can operate all of this on JSON paths. And because this is an embedded document, we can't use just the default, which is a hash anymore. We have to go in and we have to change the storage type to JSON. And to change the storage type to JSON, all I have to do is set storage type to JSON, and then I have to go back into my Muppets and add some new addresses for them. So let's say address equals new city equals Los Angeles. Probably didn't spell that right. And zip code equals, let me find LA. I'll find an LA zip codes. No, oh, that's easy. 9001 90001, and oh, that's got to be wrapped in as a text string because it's a zip code, which is a postal code, which is not really a proper number. So I'll do the same thing for all of them, except I'll use 9002 in this instance. And for Kermit, I'll also use 9003. And then all I have to do is say, same as these other ones, except in this case, I'll say x.address dot city equals, how did I spell it? I spelled it right, actually, maybe. Is Los Angeles. And that will print out all the Muppets in LA. So all three of them are in LA. And if I wanted to say which ones are in the zip code 9001, you can do that as well. Do that as well. And it will report that just Bunsen is in 9001. And the last thing we're going to look at real quickly is aggregations. So aggregations can only be performed on, right now in Redis, they can only be performed on things that are marked as sortable because those are in the index. If you want to drop down into the lower level RediSearch, you can, and issue loads to bring all these things in. But let's say we just want to index the ages. Or we just want to perform aggregations on the age and the geolocation. So I'm just going to mark both of these as aggregatable in the index. And then in here, I will create this aggregation set. And now this aggregation set allows you to do all those apply and reduce functions and stuff like that. Oh, what happened? That's weird. Anyway. But this aggregation set allows you to now go in and take these Muppets. So I'll do an await for each bar results in Muppet aggregations.apply. And if I want to apply an expression to basically the age, let's say, for example, and I want to say x.age, I want to take the Muppet's age. I would say x.recordShell. RecordShell refers to the actual instance of the object in Redis. So this would be the Muppet. And then age. And I can see how old are they going to be next year. I could just mute that null right there. And then I can store this result in age next year. And then I can say console.writeLine and I can pass in the age next year result from my apply result as the age that they're going to be next year. And if I run that, it's going to go through and it's going to take all of my records in Redis and add one to their age and report what the actual age is. I could then do things like finding the average of all the Muppets in Redis. So I could say var average age equals Muppet aggregations dot average x.recordShell.age. And that's actually going to return to me the average age of all the Muppets. In this case, it's 51.333. And then, like, I guess for my last trick here, I'm going to look at basically all of their distances from node-loops. So remember, we were looking at that example before with geolocations. I could actually calculate their distance and report that back as the result of an apply function. And I can do that by saying apply functions, which is a group of static functions that we have for just this purpose. And I can say geodistance, nobu, let's say x.record shell dot home location and nobu. And store the result of this in distance from nobus. And then here, I could say the distances from nobus is this. And this will just print out all of the Muppets distances from nobus. Importantly, this results in a calculation in meters. You can convert it to whatever unit you want using other apply functions. But yeah, so like that, we covered a lot of ground today, but that is pretty much it for me. Just another like brief overview of me. I'm Steve Lorello again. I am the .NET Developer Advocate at Redis. You can find me at slorello on Twitter or slorello89 on GitHub, or slorello.com is my website. Some resources for this talk. You can find out all about the Redis commands, all the basic Redis commands you want on redis.io. You can find out more about RediSearch on redissearch.io. You can find the RediSearch Docker image on the Docker Hub. And then you could learn more about Redis Ohm, which is the library that I just demonstrated that I actually wrote on GitHub. It's under the Redis organization, redisohm.net. And my slides are all available under my, SlideShow. And other than that, come check us out. If you want to learn more about Redis, we have Redis University, which is a bunch of free to take courses that run all the time that range from everything from like the basic Redis data structures, like we just went over, to Redis streams and Redis search and document stores and operating Redis at scale and all that stuff. And you can find us on Discord too. So yeah, that's about it. I guess, does anybody have any questions is my last question. If age was not marked as index, would the search fail? Yep. Yes, it would. So like basically with Redis search, you need to explicitly define the fields that you want to search on, right? Like because Redis is a key value store, you need to explicitly define your indexes. You can't just throw stuff into Redis and then just like query it. Like Redis, the thing about Redis is it's single threaded and it's meant to be extremely fast. But because of that, like it won't let you just scan over the entire data, the entire set of keys that you might want to look at and determine which of them sort of like match your request. So like because it's indexed, it's going to be like lightning fast to find the answer. The order of the time complexity of any query in Redis search is basically O(n), where the n is the number of documents that are going to be returned by Redis search. So it's only linear in the output, not linear in the input. Any other questions?
Going once. Hey, Steve, thank you so much for the presentation.
No worries. Happy to.
Great, everyone. If I don't see you, you all have a good weekend.
All right. Talk to you all later.
Yeah.
Bye.